there, my name is Edward Matos from Miss Irma Briseño's Probability and Statistics course. Today I will be going over a Poisson distribution problem. I have the problem on my phone right now so that I can see, but I will also try to present it right here so you can also see the problem and read along with me. So the problem states, the number of oil tankers arriving at a port between successive high tides has a Poisson distribution with mean 2. The depth of the water is such that loaded vessels can enter the dock area only on the high tide. The port has dock space for only 3 tankers which are discharged and leave the dock area before the next tide. Only the first 3 loaded tankers waiting at any high tide go into the dock area. Any others must await another high tide starting from an evening high tide, after which no ships remain waiting their turn. Find to 3 decimal places the probabilities that after the next morning high tides, A, the 3 docks berths remain empty, B, the 3 dock berths are all filled, and C, find to 2 decimal places the probability that no tankers are left waiting outside the dock area after the following evening high tide. So the problem gave us that the Poisson distribution mean is equals to 2, right? Which is also mu is equals to 2. So I will first show the general formula for finding Poisson distributions, right? Which is mu to the power of x times e to the power of negative mu over x factorial, which is equals to 2 to the power of x times e to the power of negative 2 all over x factorial, right? And in this case, the capital X is for random variable, by the way. And basically, x, the small x is what we will be putting the different variable. This small x is for these ones right here, which we will put in different values for. So for A, we want to know the 3 dock berths, that the probability that the 3 dock berths remains empty, right? So P of x is equal, P of x is equal 0, right? So which will happen is that the 2 to the power of 0 times e to the power of negative 2 over 0 factorial, right? Because 0 in this case is the value that we are placing in, right? And basically what we know is that 2 to the power of 0 is 1, anything raised to the power of 0 is 1, and 0 factorial is 1 because we know 0 factorial is 1, which can also be proven, by the way. And so e to the power of negative 2 is all we need to really worry about, which will give us this large number here, which is 0.1353352,832, which is equals to 0.135 or 0.135 times 100, which equals to 13.5%, right? But in this case, we just want to enter decimal places, so it will just be 0.135. So now for B, which states the 3 berths are all filled, right? So I will limit ourselves to 4 right now, to 4 cases, right? But we are only talking about what's happening inside the dock at this moment, right? We're not talking about if any are waiting outside or not. So what happened is that this will be P of the random variable x is greater or equals to 3, which is equals to 1. P, the random variable x, is less than 3, right? So this will have just 0, 1, 2, and 0, 1, and 2, right? Not 3 included. So we will have 1 minus the Poisson distributions of P of x equals 0, which we already have. P of x equals 0, and P of x equals 1. P of x equals 2, right? Random variable, random variable, right? So what will happen is that we want to find what we will do is add these up, and basically we will from 1, right? We will do 1 minus all of these right here. So what will first happen is that we find the p of the random variable x is equal to 0, close bracket, right? Equal to 0.135335282, which is also just 0.135. I didn't write down the whole thing over because we already did that. So we will do these now for the other cases 1 and 2, which we just have to put in the numbers for the x's, right? So 2 to the power of 1 times e to the power of -2 over 1 factorial, which will give us just 2 times the power of e to the power of -2, because we know 1 factorial is 1, right? So we just multiply that and we get 0.2706705,665. And now for the case with 2 in it now, the next case, which is 2 to the power of 2, right? 2 to the power of 2 times e to the power of -2 over 2 factorial. So in this case, we know that 2 factorial is 2 because that's just 1 times 2, right? And then 2 squared is just 2 times 2. So basically, what will happen is that a 2 will cancel out from the bottom and the top, right? So basically, we'll just have 2 times e to the power of -2, because this is just a 1 right now because we cancelled out there just now. So the answer will actually be the same thing as up here because it's just 2 times e to the power of -2, and it equals this large number here, the same as up here, right? And now I will be sticking this up here because b is not finished yet. And what will happen is that because we still, remember that we still have to minus it, right? We will have to minus 1 from it, right? So, well, not minus 1, but yeah, it will be 1 minus all of these stuff, right? So what happened is that we will have 1 minus this and this, right? What I did, I put it to 3 decimal places. So it's 1 minus, open bracket, 0.135 plus 0.271 plus 0.271, which is also for the case, these represent the cases for 0, 1, and 2. So it's empty dock, 1 ship in the dock, well, 1 tanker in the dock, 2 tanker in the dock, right? Because, so now what will happen is that it will be 1 minus 0.677 of this right here, right? And that will give us 0.323, right? Or 32.3%. So now, now I will be going over C, but before I go over C, I don't think that I did B complete justice, because I believe I said that I would just limit it to 4 cases, to 4 cases, which is if it has 1 tank, 2 tank, or 3 tank. But actually, what this is saying is that it's greater than 3 or equals to 3. So that means that the answer for this is, the answer right here is if there is 3 tanks in the dock at the moment, because B asked for that question, and it's if 3 tankers are in the dock at that moment, and it also includes if there are no tankers waiting, or if there are many tankers waiting right now. You know, so this also includes that, this, because so that is the answer for that one, right? So now this one is for if there were no tankers waiting, right? Which is basically if they had, it can have 1, it can have 0, it can have 2, or equals to 3. So at most it can have is 3 tankers in the thing without anybody waiting for another turn, right? Without any tankers waiting for another turn. So what we will do is deal with these 3 cases right here. If there's 0, 1, 2, and 3. So this 0 is 0 tankers, no tankers are waiting. 1 tanker is inside the dock, no tankers are waiting. 2 tankers inside the dock, no tankers are waiting. 3 tankers are in the dock, no tankers are waiting, right? If they asked me for question B for what is it for if no tankers were waiting, if no tankers are waiting and the dock was filled, if the question B asked that, then I would give them, I would just have to do do this working here, but instead I had to do all of this because I also had to account for if they had any tankers waiting outside the dock at the moment. All right. So then the question asks, find two decimal places the probability that no tankers are left waiting outside the dock area after the following evening's high tide. Right? So no tankers waiting. So what will happen is that, like I said, at most 3. So what I did, because we already know that P of X is equals to 1, we already know this answer, we already know this answer, and we already know this one for the cases of 0, 1, 1 and 2, right? We already know those answers. So I just put it right here back. So what we didn't do is get the case with 3, right? When there's 3, we didn't do that one. So I did the working for it. It is e to the power of -2 to the power of 3 over 3 factorial, which is equals to 0.1804478, which is also equals to 0.180, right? I did it to 3 decimal places. I forgot it was to 2 decimal places, but I did end up remembering in the end when I did the working. So now we go here, which is 0.135 plus 0.271 plus 0.271 plus 0.180. So what is this? This is case 0 for no. These are all the different cases, right? None waiting, right? Of course. So this is for a case with 0 tankers in the dock, 1 tanker in the dock, 2 tankers in the dock, and 3 tankers in the dock. And we will get, what we get is 0.857, which is also equals to 0.86, which that would basically mean that the probability that no tankers are left waiting outside is 0.86. And basically that concludes. There's no more questions, no more questions I need to answer. So that concludes my presentation for my Poisson distribution. Please feel free to send any messages if you would like me to further emphasize on anything. My apologies for the mistake earlier.